All right, Unit 5, Lesson 3, Linear versus Nonlinear Real World and Mathematical Applications. All right, so we have a falling parachute jumper with the time and his height, a falling bowling ball with the time and the height. So picture one of these things being dropped out of a plane, 1 minute, 2 minutes, 3 minutes, 4 minutes, the height, 1 minute, 2 minutes, 3 minutes, 4 minutes, and the height. The height is going down because it's getting closer and closer to the Earth. All right. So let's graph this. 0, 300, when the time is 0, the parachute is at 300. So let's see if this is 240, this would be 270, this would be 300. Right, so let's just fill in. So we're counting by 30s. 150, 210, 240, 270. Okay. The next point is 1, 285. So that would be about here. The next point is 2, 270, 3, 255, 4, 240. And that's all the data that we have. But we can connect these and notice that the rate of change is constant. This is creating a line. So if I connect those, it'll keep going. Draw arrows just on this end because he starts here and continues falling. Okay, now let's look at the bowling ball. The bowling ball also starts at 0, 300. Let me just fill in my scale. Then after 1 second, it's at 284. So that would be around here. After 2 seconds, it's at 236. So that would be just under 240. At 3 seconds, it's at 156. So that would be right about here. And at 4 seconds, it's at 44 height for the feet. So that would be in between 30 and 60, right about here. Okay, and again, I just got those from the table. This is not making a straight line. This is going to be a curved line. All right, so essential question, which real-world situation can be represented by a linear function and why? So the linear function is going to be the parachute jumper. That's the one that created a straight line. He is falling at a constant speed. That rate is continuous. Okay, and which one can be represented by a nonlinear function? Well, our bowling ball created a curved graph. The speed was getting faster and faster. It started out falling slowly, and then it fell a lot faster. So the speed is not constant. The slope is not constant. So it is falling at an increasing speed. Okay, let's figure out if these real-life situations are linear or not linear. If the rate of change in the real-world story is constant, then a situation will be linear. If the rate of change is not constant, then the situation would be nonlinear. So important to know that constant means the same, steady, continuous, words like that. And then not constant would be the opposite. So the distance traveled by a tortoise is moving at constant speed. Keyword constant tells us it's going to be linear. The distance traveled by the sprinter moves at an increasing speed. It's getting faster and faster. It is not the same speed, the same rate the whole time. So nonlinear. The distance traveled by a car is moving at a decreasing speed. Again, nonlinear, not the same rate the whole time. It's getting slower. Susie deposits the same amount in her bank account each week. That's going to be linear. It's the same each week. Withdraws and deposits money from her account daily. taking out money and then putting in money. That's not going to be continuous or the same rate of change. It's going to be going up and down. Nonlinear. The cost of a cab ride that charges a flat fee plus a rate per mile. So per mile, that's going to be like our slope, and this fee would be our b when we did y equals mx plus b. This is going to be a constant rate of change, a constant slope. It's that same rate per mile added to that same fee. Awesome. Okay, let's look at this one. The function p equals 4s gives the perimeter of a square as a function and its side lengths. Complete the table of values, then graph the function. Okay, so for a square, when there is 0 side lengths, the perimeter is going to be 0. If it has a side length, and you can get that by saying 4 times 0, because perimeter equals 4 times s, so it'll be 4 times the number of sides, which is there's 0 sides, or 0 or times the length of the side. Okay, what if the side is 1 unit long? Well, then we would take the 4 sides, multiply by the 1 unit. Again, we have our equation here, p equals 4s. So the perimeter is going to be 4 times s, which is 1, and that will give you 4. Now we're going to do 4 times 2, 4 times 3, 4 times 4, 4 times 5, and then 4 times 6. And again, we're just plugging into this equation, right? So for the last one, p equals 4s, so p equals 4 times the side length of 6. That's going to give you 24. 4 times 5 would give us 20. Okay, and we can graph this. Starting at 0, 0. Next point is 1, 4, 2, 8, 3, 12, 4, 16, 5, 20, and then 6, 24. Well, let's see, is this linear or nonlinear? Looks like a straight line to me. P equals 4s was the name of the equation, and this is linear function. Why? Well, it's a perfectly straight line. And it has a constant rate of change, right? We can see here our slope, we're going up 2 boxes, right 2 boxes, up 2 boxes, right 2 boxes, up 4 over 1, up 4 over 1. Our slope is 4 over 1. Okay. All right, that was perimeter. Now let's look at a function with area. Area equals side squared is a formula for giving area of a square. Complete this table using that formula. Okay, so we have our formula, area equals side squared. So what if the length of the side is 0? Well, 0 squared, that's just 0 times 0. Let's try 1. 1 squared is 1. What about 2 squared? Well, that's 4. 3 squared, 4 squared, 5 squared, and 6 squared. Well, let's see. 3 times 3 is 9. 4 times 4 is 16. Remember, squared just means a number that multiply that original base number by itself. 5 times 5 is 25. 6 times 6 is 36. Alrighty, let's graph it. 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, would be right above 24, and then 6, 36, would be right here. I can't just connect those with a ruler. They're curving. Area equals side squared. This is nonlinear. Why? Well, the graph is a curve not a line. Also, it doesn't have a constant rate of change. If you found the slope between these 2 points, you're going up like 3 over 2. And then between these 2 points, you're going up a lot more and then over a different amount. Or if you found your slope here, this would be change in y, so this would be 1 over 1. Whereas our slope, let's do the slope then down here. Our slope here, our change in y is going up 11 over 1. So 2 totally different slopes. And if you found your slope in the middle, it would be up 5 over 1. So your slope is increasing. Your rate of change is increasing. It is not linear. Different rate of change, different slope throughout the line. Okay, what about volume? The function v equals side cubed gives the volume of a cube as a function of its edge length. Complete the table of values, then graph the function. So let's see, do you think volume is going to be linear or nonlinear? All right, so again, the formula. Volume equals side cubed. So let's plug in 0 for our side length. 0 times 0 times 0 is 0. What about 1 cubed? That's going to be 1 times 1 times 1 is 1. 2 cubed. 2 times 2 times 2, that's going to be 8. 3 cubed, that's 3 times 3 times 3, that's going to be 27. 4 cubed, 5 cubed, and 6 cubed. 4 cubed, 4 times 4 times 4, you can use your calculator, that's 64. 5 cubed, 5 times 5 times 5 is going to be 125. And 6 times 6 times 6 for 6 cubed is 216. Let's graph it. 0, 0, 1, 1, 2, 8, 327, 4, 64, 5, 125. Oh, that's not even on here. Doesn't fit. But we can just follow the trend. Is this linear or nonlinear? It is curving. It is not linear. Y graph is a curve, not a line. Does not have a constant rate of change. Remember, rate of change is the same thing as slope. If you were to find the slope up here and compare it to the slope down here, it's going to be different. The slope at the beginning is just 1 over 1. Then the slope here would be up 7 over 1. And the slope is just going to get steeper and steeper as you go. Rate of change is the same thing as slope. Slope is not constant here. Whereas remember, in the perimeter one, the slope was the same the entire time. It was always going to be up 4 over 1, up 4 over 1. So the rate of change is always 4 for the perimeter. For the area and the volume, it varied. So it is not linear. Okay, and then we just have some summary information here. Linear, perimeter, and circumference formulas. We didn't talk about circumference, but you did that in 7th grade. Circumference equals pi times diameter. Perimeter equals 4 times the side, not however many, whatever the length of the sides are, or side plus side plus side plus side. You could write it as 2. Whoops. Nonlinear would be our area formulas and our volume formulas. So here we did area equals side squared and volume equals side cubed. And then here's just some more reference sheets. This is actually the reference sheet that, you can use with all the different formulas on the state test. All right, thanks for watching.